Section 10.8, we're going to talk about circles again. This is the last section of this chapter. I've been accused of saying this a lot, and they're probably right.
This is easy.
This is easy, that's right. This is probably the easiest.
You said that before.
Now, listen, I'm telling you, this is probably, you'll agree with me at the end of this, okay? This is probably the easiest lesson that we do on the circles, okay? It probably is. I think it is.
It's easier than the
I said that about the last one?
You know when it's hard.
Is
it easier than the
Yeah.
section?
Be afraid when I tell you this lesson is very, very hard, okay? Because
Will you ever say that?
I don't think I will.
You said it before.
Okay, here we go. Did I say it was hard?
Yes.
Okay. All right, let's take a look at this. Here's a circle. All right. Actually, let's not even start with the circle yet. Let's do this. Are you listening? If I ask, now you're going to look at what I'm saying right now and you think, how does that have to do with circles? Well, I'll show you. If I asked you to find the equation of a line, remember we had a whole chapter on doing that kind of stuff. If I said the equation of a line, what's the first thing that pops in your head when you think of equation of a line? Slope. Yeah, I would say y equals mx plus b. And that's actually, we give that a fancy name, Slope-Intercept Form, right. Because, what is that? As soon as I see that number right there, I know that's my what? Slope. And as soon as I see that number sitting right there, I know that's my y-intercept. Okay? So if I was to see something like this, why are my equals so ugly today? 3x minus, I don't know, 5. Let's say I had something like this. Just looking at this equation, Chris, get your feet off, please. Chris.
Alex.
I can see how that could be irritating. All right, just don't do it. He asked you not to do it. Don't do it. Thanks. All right, here we go. Just looking at this thing right here, you should be able to tell what the slope is just by looking at it. So what is the slope of this?
3.
It's 3. It's not -5. Slope is 3. You said -5. The slope is 3. What's the y-intercept? It's -5. Okay, that's the y-intercept. So just looking at the equation, you should be able to tell what the slope is and what the y-intercept is. Okay? What we're going to do today is not the equation of a line, but what have we been studying this whole chapter? Equation of a circle. All right? So the equation of a circle. All right, what I'm going to do here is I'm going to draw a little x and y axis. Okay? Here's an x and y axis, and I'm going to take this circle and put it right here. I'm going to put the center of the circle right at the origin of this x and y axis. All right? Actually, I'll tell you what, let's make this a little bit bigger so I can draw on it. So now let's take the center of the circle, put it right on the origin, and there we go. Got a nice circle, center of the circle is at the origin. When I find the equation of a circle, it's not going to be y equals mx plus b, but they actually kind of make it, let's see, what color? Let's go pink. That
Yes.
pink? Magenta? Okay. All right, watch. I'm going to take, when they find the equation of a circle, basically all they're doing is finding the length of the radius. Do you hear what I just said? Finding the equation of a circle basically is just another way to find the length of that radius. So that radius is r. If I could find the length of r, that's basically what the equation of a circle is. All right? So you look at this, you're like, well, I don't have any numbers or anything. Well, you kind of do. You have a number right here, don't you? You got a 0, 0. Now, when I say find the length of r, what comes to mind that we've studied in the past? Length of a segment. Distance formula. We're trying to find the distance formula between this point and this point right here. So if I gave you 2 points, you should be able to find the distance between those 2 points. Wouldn't you agree? All right, by the distance formula. And distance formula is basically just the Pythagorean theorem. So we're back to triangles again. Isn't that funny how it all goes back to triangles?
No.
Again, I think it is. Look at this thing right here. We don't know what this point is. This could be any point. I could have drawn the radius to this in this quadrant, in the second, in the third, or in the fourth. All right, I just decided to go in the first quadrant, make it easy, but I don't know what that point is. All right, so what I'm going to do is I'm going to be real general about this. Remember, I said it could be any point on this whole entire circle. So how would I get to this point? I would go in this direction, which is the x direction, correct? And then I would go up in the y direction. So what would that ordered pair be?
XY.
It'd be xy. Good. Now, normally that would be a number, wouldn't it? I go over 3, up 5, or whatever it is. But I don't know how far over and up I'm going, so I just use x and y to represent that. Okay, yes?
But if you did it like on the line, wouldn't you already have like a 0?
Yeah, we're not going to do them on the line right here, but it would actually be easier. I mean, this would still be an xy point, right? Because it would be 0, right? So it would actually be a little easier if we did it here. Really, all you had to do is just count over on the x, because if this was x, if this was like 7, 0, right? Then distance formula says you subtract the x's, square them, right? Then you subtract the y's and square them. Well, what's 0 minus 0? It's 0. So really, all you got to do is just think about the x's, right? It'd be the same way up and down here, except the x's would go to 0 and your y's would be whatever that distance is. Right? So if it's on the axis itself, it actually is pretty easy. It gets a little more complicated when it's not right on the axis. Okay, when it's like up here somewhere. Does that make any sense? I don't know if that helped or not.
Won't they have the center of the circle on there anyway, so you can just count?
Well, the center of the circle is not always going to be at 0.
Yeah, like
Okay.
if the circle's moved somewhere else, then that's one.
Yeah, just bear with me, okay? Yeah, you could count, but that's not always the best way. What if you had to go to like 197 and this was like at negative 483 or something crazy like that? Then you wouldn't want to sit there and count over, would you? All right. So it's nice to have a formula when you get crazy numbers like that. All right. Or if they were decimals or fractions or something like that, they're not always nice, easy 5, 3, 2, 1 kind of numbers. Would you agree, guys? All right, so what we're going to do here is we're going to find the distance between these. Now, this is just one specific place where this circle could be. Remember, I purposely made the center of the circle to be at the origin. It's not always going to be there. I'm just starting off with an easy one first, and then we're going to lead up to one where the center of the circle is not at the origin, or it's somewhere else. Okay? So watch what I'm going to do. I want to find the distance of this line, r right there. Well, I'll use the distance formula. Let's put this up a little bit. So what would the distance be? Well, the distance formula is this. Remember that? Looks like Pythagorean theorem. So I put parentheses, I square, put parentheses and squared. Now, how do I find the distance of the x's? Well, I go x minus what? It's x1 minus x2, but in this situation, it's what? It's x minus 0. Good. And then the y's would be y1 minus y2, but we're going to go what? Y minus 0. Right? Let's just simplify this a little bit. What's x minus 0 is x, and then squared is x squared. This is all under a square root, by the way. Plus, what's this going to be? It's just going to be y squared. Now watch. That would be fine. That would be the length of the radius. Let's put an r here instead of d. Is that all right? Because it's the length of the radius. You can do that. That's fine. But for some reason, and I guess I kind of know, they just don't like that square root sitting there all the time. It just looks a little ugly. So they decide, let's not have the square root sitting right here. Let's get rid of that square root. But can't I just get rid of it like that? No.
It's x plus y.
No. Can't do that. Can't do that. That's... Look, how did I get rid of that square root? Well, I deleted it on my program, didn't I? But how would I do that mathematically? Say it, Austin. Square both sides. That's right. Square both sides, and that'll get rid of that square root, won't it? So watch. That goes away if I square that side, but I got to square the other side. So look, there it is. So this is a nice little equation of a circle, but what specifically is true about this circle, though? This was a pretty specific type of a circle. It was a circle where the center was where? At the... Give me a word. Origin. At the origin, okay? So this is the equation of a circle with the center at the origin. All right? So this is not really like a real general equation. This is specific for this particular circle that has the radius at the the center of the circle at the origin. You with me? I just wanted to do one that was kind of easy to see because x minus 0 was easy, y minus 0 was easy. But let's say that circle was not at the origin. You don't like it anymore? You haven't even seen it. Well, why not? Okay, look at this. Let's actually let's do this before I put a radius in there. Let's take this circle and let's move it. I don't know, let's move it down here like this. Okay? So all I did is I just stuck it in one of my quadrants. I don't care what quadrant. I put it in the third. And let's draw a radius again. And we could draw the radius anywhere. I could have drawn it here, 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 anywhere around the circle, couldn't I? I'm just going to draw right there. It's no particular magical place or anything. I just stuck it right there. Now, let's see. Now, look at this. Now, this is not the origin of my x and y axis, is it? All right? So I got to figure out another letter to call this. Now, they call the center of the circle H and K. So whoever came up with this equation, don't know. Just, you got to pick something else. Because you already picked x and y up here. I mean, you could have picked other letters if you wanted. You could have picked A and B or whatever. But they picked, listen please. Shh. Guys, concentrate. Guys are so scattered. Come on. Focus on what's going on right here. Somebody just figured out, I'm just going to call this H and K. I don't think there's anything magical about it. They just wanted to pick letters that they haven't picked before, I guess. I don't know. Maybe it was somebody's initials. I have no idea. All right. But this is going to be XY, and this is HK. Now, watch what we're going to do here. And remember, that's going to be the radius, isn't it? So let's write the equation, or let's find the distance of this radius. But this is not a 0 now, so it's not x minus 0. What's it going to be? So r equals, here's my distance formula, right? So it's not going to be x minus 0. What's it going to be? X minus h. And it's not going to be y minus 0. It's going to be y minus k. Now again, they really don't like the square root here. It just looks kind of ugly, a little cumbersome. So what do? Get rid of that square root. And so what's it going to look like? R what? Squared equals, now you don't have a square root, right? That canceled out when you squared both sides. So watch, you get x minus h squared plus y minus k squared. And that right there is your equation of a circle. And basically, remember what I said at the beginning? The equation of a circle is basically the length of the radius in a circle. That's all it is. But what does the h and the k represent? The h and k represents the what? The center of the circle. Okay? So the h and the k, hk, represents the center of the circle. Right? The r represents what? The radius of the circle. Right? So those two things. You know how you had y equals mx plus b? The m was the slope, the y or the b was the y-intercept, wasn't it? Well, it was very easily recognizable just looking at that equation. Agreed? Do you see why I wrote that down first before I did this? So you could see the slope, you could see the y-intercept very easily. So if you had an equation of a circle and you recognize what this equation of a circle represents, then you could very easily figure out what the radius is and the center. So this is the kind of stuff they're going to ask you. They're going to ask you to find the radius of the circle. They're going to ask you to find the center of the circle. Those are the two things they're going to ask you. Right? David, you paying attention? Well, it's not going to be HK. It's going to be an actual number. Okay? So for instance, here we go. What if, let's do it, they're going to ask you two different ways. Let's do it like this. What if they told you the radius of the circle was, I don't know, 3. All right? And the center of the circle, just think of a center, 2, 5. All right? Are you with me? So if they told you the radius of the circle was 3 and the center of the circle was at 2, 5, they're going to say, write the what? Equation of the circle. Of the circle. Alright, there it is. It says write the equation of a circle. Now, I know I just had it there a second ago, but let's write that down just so that we remember what it is. What is it? It's x minus h squared plus what? Y minus k squared. That's the equation of the circle. But I want to make a specific one that has the center at 2, 5 and has the radius 3. Alright, so this is the kind of stuff that they're going to ask you to do. Bless you. Alright, so let's do this. R squared. So what do we have?
9.
9, right? Because the radius is 3, so it's 3 squared, which is 9. And then look at this. I always like to write these parentheses and squares before I throw the stuff in here. I don't know. Do you? I do. So look what we do. It's going to be x minus what? 2. Right. Because this is our center. This is our h, and that's our k. See that? So x minus h, and then this is going to be y minus what?
5.
5. And there you go. That's the equation of the circle. Write it just like that. If you wanted to put that equals 9 on the right-hand side, if that bothers you, that's okay. But you could write it just like this. That's all you got to do. They're going to give you the radius. They're going to give you the center. What did I tell you? Didn't I tell you at the beginning this was going to be easy? Kind of. All right. What if I said this? What if I said the radius is the square root of 17 and the center is negative 5, 7? All right. Tell you what. I like that green for a while, but let's change it. All right, so here we go. Let's not have the equation written above us. Let's try and remember it. So what do? We take r squared, right? So what would that equal? It'd just be plain old 17, wouldn't it? Right? Square root of 17 squared is 17 equals. I like to do this. And what's it going to be? It's going to be x minus what? Negative 5, which is going to be plus 5, isn't it? Everybody see that? So it's x minus a negative, which is x plus 5. And then this is going to be y what? Minus 7. And there you go. You're done. That's the equation of the circle with that radius and that center. It's as easy as that. What do you think?
It has to get harder.
I don't think it really does, to tell you the truth. Let's go to this purple. Can we check it? Good. Let's do this one. What if they actually gave you the equation first and they asked you to find the center and the radius? That shouldn't be any more difficult, should it? So let's do this. Let's say 49 equals x plus 3 squared plus y minus, I don't know, 11 squared. Alright? And they're going to ask you two things. They're going to say find the center of the circle and then find the radius of the circle. Alyssa.
Oh, can I try?
Go ahead.
The radius is 7.
Okay.
And the equation is negative.
Well, not the equation. The
Well,
what?
not the equation, like the center.
The center of the circle is what?
Is negative 3, 11.
That's it. Now, a lot of people get mixed up. Do you see that plus and they think that's going to be a positive 3 because it's minus, right? It's x minus h, isn't it? So what are you subtracting? You're subtracting a negative 3, aren't you? It's x minus a negative 3. You see that? That's a place where a lot of people get confused on this. That's about one of the only places they get confused. But it's negative 3. And this is 11 because it's y minus k. What is k? K is 11. It's not negative 11, is it? K is 11. So 11 right there. That's it. We good? Let's use this. Alright, let's do another one. What if I said 18 equals x minus 2 squared plus y minus 6 squared. Alright, there you go. What is the center and what is the radius? Taylor?
The center would be 2, 6.
Good.
And the radius would be the square root of 18.
Very good. Let's simplify that. Can you do that in your head?
Yes.
What is it?
3 square root of 2.
Good. Because 9 times 2, right? Square root of 9 is 3. Square root of 2. And there are your two answers. What if I asked you to graph something? What if I asked you to graph? What do you think? What if I asked you to graph? I'll make this kind of easy. Let's say this.
Are we going to have to use that thingy and draw the circles?
Use the thingy? What thingy?
Compass.
The compass? It could be helpful. Or if you have a thing like that. Compass could be helpful. You don't have to. I tried to draw a circle first period. They all laughed at me because it was terrible. By hand, you know. Oh, just wait. We'll get to it. We'll get to it. We'll get to it. So, let's draw an x and y axis here, since we're going to graph this thing. Let's try this again.
Are they gonna ask us to graph paper?
Of course.
What? I don't have graph paper.
Does anyone have graph paper?
You don't need graph paper. Look, do I have graph paper up here?
No, but computer program.
Yeah, but you got a ruler, right? You got straight lines. Get a straight line, okay? Well, get a straight edge, right? Get a straight edge and Draw it just like this. If you want to use graph paper, feel free, but they're not going to give you a whole lot of these. So first of all, before we even mess with this thing, what do we know that's of importance when they give you this equation right here? You should know the center, and you should know what else? The radius. All right, so let's figure out those two things. What is the center? 2, -3. Good. That's the center. What's the radius? It's just 4. Okay? So watch what I'm going to do. Now, I'm just going to sketch this out. Okay? If you want to use graph paper, you can. I'm going to 1, 2, 3, 4, 5, 6. This might not be super accurate, but it'll be good enough.
How do you know where to put the radius?
Well, you got to start with the center first. All right, so let's start with the center. I'll graph this in yellow. It's a little brighter. Let's do the center first. Where is the center? It's 2, -3. So 1, 2, and then 1, 2, 3. About right there. Would you agree? Okay. So that's the center of the circle. What's the radius of the circle? It's 4, isn't it? So what am I going to have to do? I'm going to have to come over 4. 1, 2, 3, 4, right? Now, if you have a compass, it's really easy. Put the point of the compass right here, put your pencil right here, and do what? Woo! Just like that. Okay?
It's never steady. You try to rough it so it's stable.
Well, you got to get a good one. Okay, it's because you get a cheap one with a little rivet in it. If you get one with a little screw in it, you can always tighten it up. If you get a rivet, once it comes loose, it's loose and you're done. All right. Let's see. I should be able.
Okay, let me use this.
I don't think I can rotate it because this rotates around about the middle. Is there a way to make it rotate around?
Yeah, got it.
See, it rotates around the middle, and I don't want it to do that. It would be nice if I could anchor it, like, right here. Ah, there, I just did it. Look at that. Woohoo! Is that what I do? Just click the end of it? Okay. So anyway, the length of that is 4. Let's start from scratch so I remember how to do this, okay? Sorry, I'm experimenting on you guys, but... Alright, so right there, and... What do? I just click... Oh, I gotta hit rotate. I gotta hit R, okay? R for rotate, and click right there. Now I should be able to rotate. And, yep, just like that. Alright? Now, unfortunately, it doesn't make a nice line all around it, but you get the idea. What I could do is this. I could draw a circle, though, couldn't I?
You have to draw a circle around it.
Do it.
What's
Wait a minute. I know I'm cheating. I don't care. That's why I got the program. Alright. Wait a minute. I'm going to... Now, I tried to draw it freehand. Ooh, where is that circle? There it is. Okay, let's copy that. And let's go back. I know I'm cheating, but that's okay. But look, if you have a compass, listen, if you have a compass, then feel free to use your compass.
That's like perfect.
Wow, that was right on. How about that? So there you go. That was amazing. Yeah, so you appreciated how that worked out there, didn't you? Okay, so look, there's your circle right there. Now look, because it went 4 this way, and then it went what? 4 this way. Well, technically, yeah. Is this at 2? This is at 2. 1. Yeah. I mean, you see that if I would have drawn, on graph paper, it would have matched up perfect. And this is 4 up this way, and it's 4 down this way. And then you just draw it. If you go on First Period's YouTube, you can see my ugly circle. They all laughed at me. All right, but anyway.
I thought you didn't have their class.
First period?
I am going to look
Yeah, I
at
did.
Oh.
Okay. So anyway, there's your circle, and you just graphed it. All right. Very simple. You just graphed the circle. So you find the center, come out, the radius this way. Radius. What I would do is this. I would count the radius this way. 1, 2, 3, 4. Put a dot. 1, 2, 3, 4. Put a dot. 1, 2, 3, 4 this way. Put a dot. Kind of. 1, 2, 3, 4 this way. Again, these little tick mark line things right here weren't exactly spaced out evenly, but if you use graph paper, it'll come out nice and pretty and perfect. Use a if you're really particular about this and you want your graphs to look nice, go ahead and use a compass. Stick the compass right here, put the edge right here, twirl it around, and then you're good to go. Okay. So
This thing made a perfect circle around my radius.
let's see if I can do this again. Yep, see, look at that. See that radius? See how it goes around that circle nice and perfect like that? Isn't that cool? Alright. So anyway, there you go. Alright, that's enough. Let me give you some problems to do.
Our study hall was this video. We don't have anything to do. She'll yell at us.
I've had her all year.
She kicks.
Alright. Guys, let's be nice.
She kicks Tyler.
We're recording. We're recording.
She just.
Alyssa, be able to have a line. Okay, there's a line you can cross over, and you're getting too close to the line. So section 10.8, we're doing page 747. Sounds like an airplane, doesn't it? 11 to 26.
Mr. Herrick, do you
Yep.
have graph paper?
I do not have graph paper for you to use. Alright, there you go. So there's your problems, 11 to 26. Enjoy those.